Okay, I'm going to try a little bit of algebraic manipulation right now. First off, let's take a look at this bottom formula. Okay, now these are the formula. This is the formula sheet that you can find on my website. I want to look at that bottom formula there. Delta y, hold on. Delta y is equal to vi sine of theta delta t plus 1/2 ay delta t squared. Okay, so here's the thing. Let's say we have a situation in which you have the height, delta y, you have the initial velocity, you have the angle, you know what planet you're doing this on, so you have the a of y, which of course is acceleration due to gravity, but you don't have the time. Okay, so I'm going to show you the manipulation necessary in order to find time. First off, let's do a quick review. Those of you who have taken Algebra 1 should remember this equation here. That's the quadratic equation. If you have a formula, or I'm sorry, if you have an equation in the form of ax squared plus bx plus c is equal to 0, then you can use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. You can use this formula to solve for x. Now, how does this relate to our physics formula? Well, let's take a look. Okay, first off, I'm going to write this down on the paper here. The original formula, delta y is equal to vi sine of theta. There's a reason for me writing it like this, so I'll explain that in a little bit, times delta t plus 1/2 ay times delta t squared. Okay, now here's the problem. We know everything. We know our delta y, our vi, we know the theta, but we don't know the time. So we need to find a way to determine that time. Okay, so what we're going to do is a little bit of manipulation. One that wouldn't occur to most people right off the bat. I'm going to minus delta y from both sides. So of course this side is going to be 0, and of course delta y, negative delta y is going to be on this side. But I'm also going to do a little bit more manipulation. I'm going to take my second term and I'm going to move that to the front. So 0, sorry, that's a little scrunched up. I'll give a little space. 0 is equal to, second term, 1/2 ay times delta t squared plus vi sine theta times delta t minus, remember we're subtracting delta y from both sides, delta y. Now hopefully you're recognizing that we now have a quadratic function. Namely, this first term over here is your a, your second term is the b, and your third term is your c. So now that we know that, we can go ahead and rearrange the function and use our quadratic formula to figure out what our delta t is. So, using the quadratic formula, delta t is equal to, again, using that formula, negative vi sine of theta plus or minus the square root of vi sine of theta, and we're going to square that, minus 4 times 1/2 ay, 1/2 ay. I'm going to run out of room, so I'm just going to put my last term right down here, times negative delta y. All of that mess divided by 2a. Okay, so now that we got the quadratic formula, all you need to do is plug your values in. You have your initial velocity, you have your theta, you have a sub y, which of course is gravity on whatever planet you're on. You have your delta y, your change in vertical height. And we have, again, sorry, that should be a sub y. So basically, you have all your information, and you just need to plug it in, see what you get.